So, a relation or relations are mathematical relationships, loving relationships between inputs and outputs, or x coordinates and y coordinates.
So the relationship is a set of ordered pairs?
Exactly. So I can rewrite this as a set of ordered pairs. So anytime that I have anything that has an x and y in conjunction with each other, that's a relation. They're in a relationship. We're gonna get into like what it means to be exclusive when we get to functions. It's like next level. But relation is like the basic. It's like the basic base level. It's this relationship between an x coordinate and a y coordinate, or my input and my output. So what I put into an equation and what I get out. Examples of relations could be a set of data points like this. I have coordinate pairs 0, 2, 2, -3, 4, 4, and 8, -6.
I was so confused. I didn't see the equation first, and I was like, how did you get these numbers? Got it now?
Wait, what? What equation?
There's no equation yet.
Yeah, under the representation.
You are the only one with the notes filled in.
So stop.
Wait, why did she
Because I didn't know if we'd get through this before she left for Austria. Yes. So how do we represent relations? We can represent them in tables. We can represent them through mapping, through graphing, through coordinate points, and also, side note, through equations. So let's focus first on the list of 4 data points that I gave you. So I can represent those in an XY table where I pull out the X coordinates of all 4 of those data points and I put them in an X column, and then I take out the Y coordinates from those data points and I put them in a Y column.
Oh, this is a function.
Do you want us to?
It is a function because each unique X has a Y value.
Do you want us to fill this out?
Yes.
Every Y has its X.
Relations, man. I can also map them. So this is a good chance to start putting your data points in order from least to greatest. You don't have to do that in a table because in a table you want them associated with their relationship. In mapping, we show the relationship through arrows. So I'd have my inputs or my X values in one bubble and my outputs or Y values in my other bubble. And then I draw arrows to represent which X goes with which Y, or which input goes with each output.
Where's the
I can also show these points. I can also show these points through graphing. So I have point 0, 2 here, point 2, -3 here, point 4, 4 here, and point 8, -6 here. So I can show those all through graphing as well.
doesn't show them in our graph because it doesn't go for
I know, the graph is like the bubbly word on yours. Make it whatever you want.
Yeah.
And then in that 4th column, you guys can put in coordinate or data points, and you can represent it through this way. Or you can just draw an arrow up to the example and say coordinate or data points. The reason why I threw this side note in here is because equations also allow me to see relations between outputs and inputs. Because I can plug in values for X here to get output values for Y here. So this is another way of modeling a relationship between mathematical variables. Or I could put a Y value in here to solve for X over here. If I put X equals 2, I could then plug that in, Y equals 3, 2 squared plus 7, so that'd be Y equals 12 plus 7, Y equals 19, so this would be 2, 19 would be my relation here.
Oh, this is before.
Oh, okay. I have a question.
Mm-hmm.
On the representing relations, like
because those are numbers I chose to use for the notes.
Okay, but what is the equation that you just used? It's y
The one that
equals-
you have.
Okay, yeah. So, but the table does not correspond with that.
Yes, that's fine.
Oh, I thought it was supposed to, and I was like,
No, you're good.
this young messed up.
Yeah.
Is that
Can you pan me? Oh, maybe. Aha! Okay, so how do we describe this then? So we know that relations are mathematical relationships between outputs and inputs. We know how to represent them now. How do we describe the data that we get? Well, we can describe them using domain and range. Thanks so much for asking. Domain are the input values. Sometimes I can list these as an interval. If I have a line, it's like a multitude of numbers in there, like an infinite number of solutions in there. Or I can use list form. So domain are all my x values or my independent variables. So that's domain, is input values or my set of x values. So the domain of my example would be, in roster form, would be 0, 2, 4, and 8, because these are the numbers I have here, 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 and here for my x's. On the flip side, range are all my output values, or like how many, like what is the range of output values I can have. Here I just have specific data points, so I can't graph them. So these are not part of a line, these are just 4 unique points. So I have to list those in roster form here as well. So these are all my y values that I have as part of this set. So I have -6, -3, 2, and 4. So when I'm listing these, especially in roster form, if I have multiple of the same number in my range, I don't have to list it twice.
So if it was like 0, 2, or then 1, 2, you wouldn't have to.
Exactly, I would just put 2 ones in the range. And the reason for that is that the reason why it's range and not domain is that if I have multiple of the same number in the domain, it won't be a function. And I want to know if it's a function or not, but it doesn't matter if I have the same numbers.
It doesn't matter in the range.
Yeah.
wait, why not?
Because so in a lot of things we're talking quantity is what matters, but here is just giving me the values that are represented. So if I already write down that 2 is represented and there's another 2, it doesn't make any difference for me to have another 2.
But why do you do it for range?
So when I get into functions, functions need to have what makes a function different than a relation is that functions have all unique x values, but they can have the same y values.
Are we gonna do a toolkit function?
Yeah. Oh yeah. We're gonna dive deep into that toolbox.
A vertically compresses it, right?
We'll get there.
As D moves up or down, C moves up or right.
Yeah, in the opposite of C.
We'll get there.
C is
Anyways.
inside the
We're like a little while away from that. So why don't you guys try 1 through 4 of the examples below to get domain and range of each of these relations.